So this morning we're going to finish working on this 2007 Dodge Ram 1500 Hemi with the CAN bus issue. Here's a description of the CAN bus in this. It says here the CAN bus is a two-wire multiplex system. It's multiplexing as any system and enables transmission of multiple messages over a single channel or circuit. CAN bus is used for communication between all vehicle nodes. However, in addition to CAN bus, certain nodes may also be equipped with a dedicated serial controller interface or K-line serial link bus to provide direct communication between that node and certain inputs. It says there are actually three separate CAN bus systems used in the vehicle. They are designated CAN B, CAN C, and Diagnostic CAN C. The CAN B and CAN C system provide onboard communication between all nodes of the vehicle. The CAN C is the faster of the two systems, providing near real-time communication, 500 kilobytes per second, but is less fault-tolerant than CAN B. The CAN C is used exclusively for communications between critical powertrain and chassis nodes. The slower 83.3 kilobit but more fault-tolerant CAN B system is used for communication between body and interior nodes. The CAN B fault tolerance comes from its ability to revert to a single wire communication mode if there is a problem in the bus wiring. Now you'll recall there was one wire that was physically broken off of the TIPM in this thing. I'll put a link to the previous video in the description. That explains why the vehicle still worked properly or semi-properly until the other circuit failed as well. The two circuits are not the same. I assumed because they were both called CAN, and every CAN circuit I've looked at with a lab scope always looked the same, about a 2.5 volt. So here is a chart that shows you the values that you would see on those circuits. Now they don't use a lab scope, but they're using a voltmeter. CAN C circuits. You can see it. Bus idle is 2.4 to 2.5 volts. And you can see it goes up and down. But the CAN B circuit, look at this. CAN L, which is low, is 10.99 volts with the bus asleep. CAN on is 4.65 to 4.98 volts. And the other one is 0 to about 0.5. No wonder, I'm looking at this circuit and it doesn't work the same way as the CAN C circuit. It's completely different. So we are going to replace the TIPM in this thing this morning and go through the process of configuring it. I believe it's plug and play. It's a Dorman part. We're going to find out what's involved. And we're going to also repair that terminal that was broken off of the connector on the, I think it was the CAN L wire. So I needed one of these terminals, so I went to the local wrecking yard here, and I got a previously enjoyed connector from one of the TIPMs out of a 2008, which is the same. And this is the exact same connector here. Now the interesting thing is I took this connector out of a running truck, and you'll notice the third pin down on the top row. That's the same pin 11 that was corroded off, and it's also corroded off on this used connector. Now that's okay, I can use one of the other terminals in here, depin it. But we're going to have to repair that wire. But I just find it very interesting that the same pin has failed on this 1 year newer truck. So that seems to be a common issue. Third pin down, I think that's pin 11. So here you can see the connector that is on the truck has the same failed terminal, so we have to get this terminal out of here. Now there's a white secondary lock that you have to pry out, and then once you pry the secondary lock out, there's a little plastic release pin that you have to grab with a pick of some kind and pull off to the side while you pull on the wire. Now the problem is this wire is non-existent. The terminal is corroded, and I don't want to cut and splice all of the wires if I can avoid that, so I just want to pick out this one terminal. I should be able to get that out of there. Shit. Oh well, I've got one terminal out of the other connector. There it is there. So there's like a little plastic lock that locks into the bottom. And it's not the right color wire, but it doesn't matter. It's just a wire. So we'll try and get that piece out. So one of my viewers suggested this deoxit spray for removing oxidation on terminals. Brake cleans will remove grease and oil and clean moisture, but this will apparently remove oxidation from a terminal. So we're going to give it a try. It's not cheap. It's about 38 bucks a can, and it's only a 5-ounce can. I ordered a couple off of Amazon, and nobody locally sells it. So we'll see how it works. Well, that was fun. I literally had to take the remainder of that terminal out of there in powder. So now we're going to splice this wire and reconnect the new TIPM and follow the instructions on programming or setting it up. I've also started using this Stabilitant or Stabilint 22A on sensitive connections like these CAN bus wires. So I put a little bit of this liquid, which is supposed to enhance electrical conductivity, on these terminals. This little bottle is like $140 Canadian, so that's like 50 American, but still expensive. So here's the procedure. Make certain to disconnect the battery, which we've done, replacement, install the TIPM, reconnect the negative battery cable, insert the key and turn it to run for 12 seconds. Turn it off for 12 seconds, and then turn it back on. Clear all stored codes. Following the installation and learn procedures, NARM will have several history diagnostic codes in the totally integrated power module, powertrain control module, instrument cluster, cabin compartment node, transmission controller, so clear them. We'll reset all personal settings, customer program features. The original instrument cluster and powertrain control module must be installed and functioning properly to powering up the new totally integrated power module. Receive vehicle configuration data from the cabin compartment node. That's the instrument cluster in case you didn't know. And the vehicle identification number information from the PCM. So we're going to give that a shot now. The battery's hooked up. Module's installed here. I'm going to turn the key on for 12 seconds. So the moment of truth. I've turned the key on for 12 seconds, off for 12 seconds. Now I'm turning the key on. Gauges work. Does it start? It's a beautiful thing. No messages on the dash, no warning lights. We're going to scan it and see what codes it's got. So we're going to do a network scan of this thing now and see if it's got any codes in it. It says it's normal for there to be several codes after initializing that TIPM. And then we'll clear them all. The customer mentioned that there was a problem with the wipers, and I suggested that the wipers obviously are networked as well. Code scan, pre-scan. So this will take several seconds. So pick up when we're scanned. Implausible missing ECU network configuration, airbag, lost communication with vehicle security, cabin compartment node. Yeah, we got several codes in here. 7. Seven modules so far, 8 modules, 9 modules, and of course the OBD2 side of the PCM is considered a separate module. So we're going to back out of this and clear all codes read by code scan. And of course, with a Chrysler product, you have to do this with key on, engine off. Some modules will clear while it's running, but they always recommend key on, engine off. I noticed lately Ford is doing that, and so is GM. Usually the code clear process is fairly quick. Doesn't have an entertainment system. Does have a wireless control module. Okay. So I'm going to hook up the lab scope and have a look at those CAN C and CAN B signals, just for future knowledge. This one is fixed now, it appears. So there's the 4 channels back pinning. The yellow channel, channel 1, is on CAN C plus. The green trace is on CAN C minus. The red trace is on CAN B minus, and the blue trace is on CAN B plus. You can see this is a lot faster. Now it's not running. I'm going to start it, see if it looks any different. Key is on. I'm going to shut the key off and we'll see what it does. According to the information, one of these should go to about 11 volts. Right now, both these channels are sitting at 5, or 2.5, sorry. There's 2.5 volts there on the green trace. I kind of like the CAN C went to sleep. There's no activity on CAN C at all. But we still got CAN B, which is cabin compartment stuff. Hasn't gone to sleep yet. Well, that's definitely a lot better than what we had before. I still would have liked to have seen it cleaner than this. Let's try changing the time base. Let's go to 200 milliseconds. Still looks awful dirty. Let's put the trigger on this channel. I don't have the trigger set up. Where's the trigger slope here? Oh, there it is right there. The plus sign. Well, it still hasn't gone to sleep. Let's pause it. And let's look at the values. So channel 1 and 2 are roughly 2.5 volts. Channel 3 is 2.7. Channel 4 is 2.3. But it maxes out at 5 volts. So from 0 to 2.7 and from 4.9 to 1.6. Interesting. Well, we're going to definitely save this recording for future reference.